In this video, I introduce FCOS, fully convolutional one-stage object detection. Anchor-free FCOS is a fully convolutional one-stage object detector in a per-pixel prediction fashion, which uses all locations in ground truth bounding boxes on feature maps as positive samples. Backbone of FCOS uses 800 by 1024 image as an input to generate multi-level feature maps C3, C4, and C5. And the multiple level features P3 to P7 are used for classification and regression. An extra layer parallel to classification branch is used for suppress the low-quality bounding boxes. The ground truth bounding box I is defined as a BI, where x0, y0, and x1, y1 denote coordinates of top left and bottom right corners of a bounding box I, respectively. And CI is a class label of object I, as shown here. FCOS directly handles the locations in a bounding box in feature maps as training samples. For example, X, Y is considered as a positive sample if it falls into any ground truth box, and the C star of the location is the class label of the ground truth box. Otherwise, it's a negative sample with a C star 0, as shown here. Regression targets are for offsets from locations are defined as L star, T star, L star, and B star, as here. FCOS can use as many positive samples as possible to train the regressor. FCOS further computes the regression targets L star, T star, R star, and B star for each location on all feature levels. Next, if a location satisfies some maximum L, T, R, B star larger than M, I, or smaller than MI minus 1, it's set as a negative sample and thus not required to regress a bounding box anymore, where MI is a regression boundaries, namely the feature map P3 has a regression range 0 to 46, and P4 has a range from 64 to 128, and so on. If a location is assigned to more than one ground truth boxes, FCOS chooses the ground truth box with minimal area as its target. The centerness branch is used to predict the centerness growth of a location by using this formulation, as shown here, which describes the quality decay of a bounding box from the object center to a location on the feature map, as shown here. FCOS predicts a C-dimensional vector P of classification labels and 4-dimensional T bounding box coordinates. 4 convolutional layers are added after the pyramidal feature maps for classification and regression. The loss function L is defined as a sum of 2 terms, where L classification is a focal loss, and L regression is a IOU loss. NPOS is number of positive samples, and C score is a centerness score to suppress the low-quality bounding boxes. The summation is calculated over all locations and POS on the feature maps. The indicator is 1 if C larger than 0 and 0 otherwise. During inference, an input image passes through the FCOS network, which generates classifications gross P and offset T for each location on the feature maps. For more details, please check with these references. Thank you. Bye.